Okay, now on to subtopic 1.2 in SL. So in this subtopic, it's basically all about arithmetic sequences, and we'll basically be going over these key points here. Now, the applications analysis models, these are usually for IAs or longer questions, but if you are familiar with this section here, you should be fine with the rest. So we'll try to focus on understanding this part first. Okay, so these are the two basic formulas you need to know for arithmetic sequences. Let's start by defining each term. So UN is the nth term, okay? And I'll come back to that because sometimes students struggle to understand what the nth term actually means, right? U1 just means first term. N just means nth, okay? And D is the common difference. So these are what we need to know. Okay, so going back to the concept of nth term. First, we need to understand what an arithmetic sequence is. An arithmetic sequence is a sequence of numbers. In this case, we can just write the most basic sequence. 1, 2, 3, 4, 5, etc. A sequence of numbers with a common difference. Okay? And a common difference means between the first and second term, and second and third term, third and fourth term, there is the same difference. Okay, what I mean by that is if we take the second term and minus the first term, we'll get 1. If we take the third term and minus the second term, we'll also get 1. And if you keep doing it, you'll find that the difference between each adjacent set of numbers is 1. Hence the term common difference. So what does the nth term mean? Well, nth is sort of like an arbitrary definition for any term in a sequence. The second term could be the nth term. The fifth term could be the nth term. The kth term could be the nth term. Now, I know that sounds a little bit confusing, but the applications will be a lot simpler when we get to them. So it's basically saying if we want to find the UN, the U second term, and we substitute U first, U1, plus N we chose UN to be second, so N must be 2 minus 1 times the common difference, which we established to be 1 in this, right? Therefore, if we want to find the second term without knowing what the second term is, we simply need to substitute this equation, which we already did. So 1 plus 1 times 1 is 1 plus 1, which is 2. How does this formula work? Well, if we want U3, for example, and U3 is basically just U1 plus D, right? Because U1 plus D, the common difference gives us U2, and U2 plus D yields U3, right? Which means, in essence, if we simplify this part right here, U3 is the same thing as U1 plus 2D, or 2 is actually just 3 minus 1, which is why it's equal to U1 n minus 1D. In this case, it's 3 minus 1, giving you 2. And that's how we get this universal equation here. Now, the second equation is for the sum of nth terms of an arithmetic sequence. Now, sum can either be written as Sn, or sometimes people like to write sigma, and we'll get to that later, sigma notation. But Sn is basically the sum. So if we want to find Sn, we can use these two equations right here. And none of the terms are new, so we should know what they all mean. Basically, if we want to find S8, that just means of this sequence here, we want to find, instead of what the 8th term is, which is what we'll find using the first formula, we want to find what is the sum of the first 8 terms. So instead of commas and looking for this term, we will be having plus signs in between every single one and adding them all up and seeing what the first 8 terms sum up to. Okay, so in this case, a simple example would be S4 being 1 plus 2 plus 3 plus 4. Okay, and we stop at 4 because it's S4, the sum of the first 4 terms. We can either just add it up if we're given the numbers, or you can use these formulas, and this is usually when you don't have enough information. Now, a quick thing to note here is that there are 2 equations for Sn, but they're actually the same equation. Because if we look at this equation, n onto u1 plus un, right? Un, we actually already have an equation for un, which is the nth term of an arithmetic sequence right here. Which means we can just substitute this guy into the equation as un. So if it's substituted, we can just write it like this. Okay, and you'll find if we simplify this down, we're going to get n plus 2 is u1, whoops, u1 plus u1, meaning it's 2u1 because it's two of them, plus n minus 1 times common difference. And that's the same equation as this one. Okay, so with the first question, we are given the first three terms of an arithmetic sequence, and we want to find the common difference. Okay, find d. Since it has nothing to do with sum, we can just rule out this question, this equation, and only focus on the first one. Actually, there are two ways to solving this, but we'll use the equation method first. So if we want to use this equation, let's say this is u1, this is that means this must be u2 and this must be u3 because it's an arithmetic sequence, right? And it's the first three terms. And let's take u2 for example. So un, or in this case u2, equals u1 plus 2 minus 1 times d. Now, we know what u1 is, and we also know what u2 is because they were given in the question, right? So we can just substitute this. 2 minus 1 is 1, 5 plus d, okay? And we'll find that d is 1.7. Now, this is the formula method, but then a simpler method to do this question would just simply be doing 6.7 minus 5, giving us 1.7. Now, the reason why we can do this instead of the formula is because the questions has already established that these are the first three terms of an arithmetic sequence. And we know the properties of an arithmetic sequence being a common difference, right? It means between u1 and u2 there's a common difference, which is the same as the difference between u2 and u3. And since this is the first term and this is the second term, all we need to do is just minus the first, subtract the first term from the second term, and we'll know the common difference. Okay, as simple as that. Okay, so next part we have the same three terms in the arithmetic sequence, and this time we want to find the 28th term of the sequence. Okay, and this is where the formula comes in. So if we want to find the nth term of the arithmetic sequence, in this case, the 28th term, u28 equals u1 plus 28 is n, so n28 minus 1 times d. And we know what d is, it's just 1.7, which we worked out from the previous part. We also know u1 is 5. And now we have this equation, okay? And if we solve this, we will find what u8 equals to. And it should be 50.9. Okay. So that's the 28th term of this sequence. Now, next question. This is a little bit trickier. We have an arithmetic sequence. Find the value of the common difference. Okay, so we're looking for d. We know what u1 is, and we also know what un is. Now, do not get mistaken. This is not the un that we want. Even though we know what un equals to, we do not know what n equals to. Okay, and that's actually in the next part. So we won't be able to solve this either, meaning we'll have two unknowns being n and d, and that will not be solvable in one equation. Therefore, this is actually our un. Okay, so if we have a look at this equation, un would actually just be u20, okay? Equals u1 being 7, plus n being 20, because u20, minus 1 times by the common difference. Now, this is what we're looking for. We can substitute u20 for 64, because that's given in the question. And now we have another simple algebraic question. Subtract both sides by 7, we get 57 equals 19d. Divide both sides by 19 and d will equal to 3. Okay, so that's our common difference. So part B, find the value of n, and n being this n here. Okay, so this is a little bit of a different question. We are given un in this case. Okay, we're given the nth term. So for example, we have a sequence 1, 2, 3, and then we have 7. Okay, we know 7 is one of the terms in the sequence, but we don't know which term it is. Obviously, in this case, we'll know it will be the 7th term, but in this case, it's very hard to tell what 3709 would be, okay, which term that would be in the sequence, which is why we need to opt for this equation again. Okay, so substituting everything into our first equation right here. Un we know to be 3709. U1 we know to be 7 plus n, this is what we want to find, minus 1 multiplied by d, which is what we already know. Okay, so now we have one equation with one unknown, and we know how to solve that. N will end up equaling 1, 2, 3, 5. I did not do that in my head, if you were wondering, by the way. Okay, so next. Okay, so this is part C of the question before. We're given the same three terms of the arithmetic sequence, but in this case, we want to find the sum of the first 28 terms, okay? Which means we will have to opt for the second equation, which is this one right here. Now, how do we use this equation? Well, Sn being the sum of the first nth terms, we basically know what we want to find, the sum of the first 28 terms, right? Now, which equation do we want to use? Well, we can either use Un or the one without Un. So this one is if you have less information, this one is if you have access to Un as well. And using the information that we had before, let's just go back and check. Okay, I deleted everything, nice. Okay, here they are. So, U28 is 50.9 and D is 1.7, okay? Which means we have Un, because U28 is 50.9, right? Meaning we can use these numbers. So N would be 28, because S28, onto U1 we know to be 5, plus 50.9 being Un, okay? We don't actually need to know what D is, because again, we used this extra section is for you to find Un. And since we already know Un, we don't need to have D anymore, okay? And this will end up equaling 782.6. Alright, now I just want to lastly go over sigma notation. So sigma notation is basically stuff to do with this symbol here. This is capital sigma, a Greek letter. And what it means is the sum of however many terms. Okay, it just means the sum of. So sigma notation is accompanied by a number on top and a number on the bottom. Usually we'll have something like n equals 1, and we'll have a number on the top as well, for example, 3. Okay? And here on the right side, we'll have something like 3n plus 5. And this is actually a series, okay? It's a sum of 3 terms. So how can we decipher what sigma notation tells us? And let's break it down to make it a bit simpler. And looking at this bottom number right here, I just changed it to n equals 0 to make it make more sense. What it means is for the first term that we're going to add, n is going to be equal to 0. And if we substitute n here, we're going to find the first term will be 3 times 0 plus 5, and that will be our first term, okay? And since sigma means the sum of, we're going to have a couple more terms, right? So this is where this number comes in. 3 means where we stop, the last n. And what I mean by that is n is going to increase by increments of one number, right? It's going to do this. And it's going to stop at n equals 3, okay? This is not going to show up. It's going to be n equals 3. Meaning we're going to have, if we substitute n equals 1, we're going to get 3 multiplied by 1 plus 5, summed with the next term, which is 3. We substitute 2 for n, in this case. And last term, see if we can squeeze this in. 3 times 3 to the power of 5. This is actually just an arithmetic sequence, because if we simplify it, this is 5, this is 8, this is going to be 12, sorry, this is 11, this is 14. And looking at these terms, if we add them together, this is actually an arithmetic sequence with a common difference of 3, positive 3, okay? Because there's the same difference. And all sigma means is the sum of this expression, where we substitute n equals 0 all the way up until n equals 3, and we add up all the terms, as we can see. the right hand side. 38.
全都是泡沫。